What is enriched uranium? Enriched uranium is not only used for nuclear energy and weapons, but also has applications in medicine, industry, and research. For example, enriched uranium can be used as a radiation source for cancer treatment, as well as for detecting and measuring the thickness of materials in industrial settings. In addition to its practical applications, enriched uranium has also played a significant role in international politics and diplomacy. The possession and development of enriched uranium is often viewed as a symbol of power and prestige, and has been a source of tension and conflict between countries. The history of enriched uranium goes back to the early 20th century, when scientists discovered the potential of nuclear energy. Since then, many countries have invested heavily in nuclear technology, both for peaceful and military purposes. The development and production of enriched uranium has been a key part of this effort, and has led to significant advances in science and technology. However, the use of enriched uranium also carries significant ethical and environmental considerations. The production of nuclear materials can have serious health and environmental impacts, and the potential for nuclear accidents and proliferation remains a major concern. As countries continue to grapple with the challenges and opportunities of nuclear technology, the role of enriched uranium will continue to be a topic of debate and discussion. It is important that we approach this issue with caution and responsibility, and work together to ensure that nuclear technology is used for the greater good of humanity. Nuclear weapons made of enriched uranium. Nuclear weapons made of enriched uranium typically use uranium-235, which is the isotope of uranium that can sustain a chain reaction. Uranium-235 makes up only 0.7% of natural uranium, so it must be enriched to increase its concentration. Enrichment is a process that separates uranium-235 from uranium-238, the more abundant isotope. One common method of enrichment is gas diffusion, which involves converting uranium into a gas and then forcing it through a series of membranes to separate the isotopes based on their weight. Another method is gas centrifugation, which uses spinning cylinders to separate the isotopes. Once the uranium-235 is enriched to a sufficient level, usually around 90%, it can be used as the fissile material in a nuclear weapon. In a nuclear weapon, a small amount of enriched uranium is compressed by conventional explosives to create a supercritical mass, which produces a nuclear explosion. It's important to note that the use of nuclear weapons is highly controversial due to their destructive power and potential to cause widespread harm. The production and use of nuclear weapons are also subject to international treaties and regulations. How can enriched uranium be used for non-weapon purposes? Enriched uranium has various uses beyond nuclear weapons. Some of the most common uses of enriched uranium are: 1. Nuclear power generation. Enriched uranium is used as fuel in nuclear power plants to produce electricity. 1. Nuclear power plants use nuclear fission to generate heat, which is then used to produce steam and drive turbines that generate electricity. 2. Medical applications. Enriched uranium is used in the production of medical isotopes, which are used in diagnostic and therapeutic procedures. 2. For example, enriched uranium is used to produce molybdenum-99, which decays into technetium-99 a widely used medical isotope. 3. Scientific research. Enriched uranium is used in scientific research, particularly in the study of nuclear physics and nuclear reactions. 4. Industrial applications. Enriched uranium is used in various industrial applications, such as in the production of aircraft and armor plating, as well as in the oil and gas industry for exploration and production. It's important to note that the use of enriched uranium in these applications is tightly regulated to prevent it from falling into the wrong hands and being used to make nuclear weapons. The International Atomic Energy Agency, IAEA, oversees the use and transport of nuclear materials and works to prevent the proliferation of nuclear weapons.